Personal finance practice problem using Excel. Future value of an annuity calculation using monthly periods. Prepare to get financially fit by practicing personal finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we're down here in the practice tab as opposed to the example tab. The example tab, in essence, being an answer key. Information on the left-hand side, going to populate that into the blue area on the right-hand side. We have a savings type of scenario. We're going to imagine we're going to invest each month $1,000, not per year, but per month. We're going to do it for 1.5 years on a monthly basis. The rate of return is going to be the 12%. We're assuming that's the yearly rate. So when we think about the monthly component for it, we'll have to break it down to a monthly rate, which would be the 12% divided by 12, or 1%. So first, let's think about the number of periods that will be covered here. If we're going to talk about 1.5 years, 1.5 years, we're going to take that 1.5 times 12. That would give us 18 months. So the number of periods we have in months will be 18 months. We're going to put in 1,000 per month over that 18-month or 1.5 years at the yearly rate of 12%, which would be a monthly rate of 1%. Let's first think about that with a table. That's going to be the starting point with this type of investment, which I think is most intuitive to think about. So I'm going to say this is going to be from period 1, 2, and so on. Notice I'm starting at period 1 instead of at period 0 because we're looking at an annuity here, and typically the annuity is calculated at the end of the period, so we'll start at the end of the first period. Selecting those two items, I'm going to drag that on down to our 18 periods. Obviously, this running balance calculation table is longer when we're talking about monthly period instead of a yearly kind of calculation. But with Excel, easy to do. We can just drag it on down, not a problem. We're going to center that by going to the alignment group and center. And so there we have it. Now, this might be interest. I'm just going to call it an increase because it could be interest, or it depends on the investment that we are in as to the format of the gains or whatnot that we will be getting from it. And we're going to say that the payment will be $1,000. So that's going to be the payment that we're putting in to the investment. We're going to say that happens at the end of the year, therefore no interest accruing on that first payment. So that's going to be simply our starting point at that $1,000. Then a year later, we're going to have what our increase would be, which would be interest or dividends or basically gains if we're in stocks and whatnot. And we're going to assume that that's at the 12% gain, which is the yearly rate, but we're talking about months in this case. So we've got to take this 1,000 times the 12%, that would be per year, divided by 12 to get the monthly amount, which would be around $10. Now, if we thought about that in the trusty calculator, you could do it a couple different ways. Normally, I would do it like this if I had a calculator and I had to do it by hand, right? 1,000 times the 0.12, the yearly rate, would give us the interest if it were for a year, 120 for a year, but it's per month. So I got to take that and divide it by 12. So we get the 10, or you could think about it this way, which is kind of the way you need to think about it when you're looking at Excel functions, which would be the yearly rate, 0.12, divided by 12 for the monthly rate of 1%, and then times the 1,000, and that would give us our 10. Notice that that rate that we used, the yearly rate of the 12%, is nice and even, so we can divide it by 12 and get the monthly rate of 1. That's not always the case when you're doing that process, but for book problems, that could be necessary if you're going to be using things like tables. Having ugly looking numbers that are below 0 and or not nice even numbers is not a problem when you're doing this in Excel. Okay, so then the next payment is going to be the payment of 1,000. And now we're going to say that, and let's make the payment, well, then we're going to say this will equal the 1,000 plus the SUM, shift 9, left arrow, holding down shift, left again, closing up the brackets. So that would give us the 1,000 plus the 1,000 plus the 10, or the 2,010. Let's do it a few more times, and then we'll do the autofill to copy it down. We'll do it then the easy way, in other words. Let's go ahead and say this is going to be the 2,010 times the 12%. We're going to take that and divide it by 12, and that'll give us tab 20 about. And then we're going to say the payment is going to be the same 1,000 that we're putting in every month on a monthly basis. This is going to be the prior amount plus the SUM or sum, shift 9, left arrow, holding down shift left again, closing it up, shift 0, enter. So the 2010 plus the 20 plus the 1,000, 3,030. Then we're going to calculate the 3,030 times the 12%, then divided by 12. Then I'm going to select tab, and the payment will once again be 1,000. So our new balance is going to be the 3,030 plus the SUM, sum, shift 9, left arrow, holding down shift left again, plus the 1,000 and the 30. Closing up the brackets gives us 4,060. Let's do it one more time, and then we'll go back and do it the easy way. This is the 4,060 times the 12% divided by 12. I'm going to select tab. Payment is going to be equal to 1,000, tab. This is going to be the prior 4,060 plus the SUM, sum, shift 9, brackets of the 1,000 and the 40, closing up the brackets, and there we are at the 5,101. Now we're going to go back and do it again, but thinking about how we can autofill so we can do it the easy way. So we're going to select these cells and delete them. We're going to delete them and start all over again, but that's okay because this time the easy way. This is going to be the 1,000 times the 12, and that 12 is outside the table, so I'm going to make it absolute by selecting F4 on the keyboard. Then I'm going to divide this by 12. That 12 is hard-coded or typed in, and therefore it will be copied down as we copy the cell down. No need to do anything special to it for that to be the case. Then we're going to say this equals the 1,000. That 1,000 needs to be the same cell when I copy it down. So we're going to make it an absolute reference, selecting F4 on the keyboard, $ before the B and the 3. Then we're going to say this is going to be equal to the one above it, plus the SUM, sum, shift 9, the ones to the left, and close up the brackets. Although this is a more complex formula, everything's in the table. Everything should move down relative when we copy it down. Nothing special needed, no absolute references, therefore. Now let's go ahead and select those 3 cells. Use our autofill handle, clicking on it, dragging it on down to 18 periods, and at the end of the day, at the end of the time frame, we get the 19,615 about. So that's going to be our ending result. Let's calculate it again, this time using the future value of an annuity calculation in Excel, the function. These 2 components are probably the things that would be most useful in practice. Then we'll move to the mathematical formula and the tables, things you might often see in a school setting more likely. Let's go ahead and hide some cells, putting our cursor on column C, dragging over to column G, C to G, right-click those cells and hide them. Then we're going to do our calculation here. I'll do it a little bit more quickly because we've seen it in the past, pointing out the new things that will be here. This is going to be negative to flip the sign, future value, shift 9. The rate is going to be that 12%, but that's a yearly rate. So we're going to divide that by 12. That's the new thing. That's the new thing we're doing here. Then comma, number of periods would be years if it were yearly, but no, now it's the 1.5 years times 12 or 18, which we already have. So I'm going to be picking up the 18 instead of the 1.5 years to 18 months, comma, payment. Payment is going to be the 1,000, which is pretty straightforward as long as we make sure that we know that that's the payment per period, which in this case is per month. Okay, and then we're going to say enter. We got that 19,614. Let's add a couple pennies this time. Home tab, alignment, couple pennies on the decimals, 19,614 and 75 cents. Now let's do it the mathematical formula way, and we'll point out the differences that happened here, which will be with the rate and the periods again. So let's put our cursor on column. I think that's H. I can't see it too well because it's it's hidden. But that skinny column, we're going to go to that one, on over to J. Let go, right-click, and hide those cells. We're looking at the formula down below, which is the future value of an annuity calculation, which is calculated as P times 1 plus R, R being the rate, not the 12%, but 12 divided by 12, which would be 1%, to the number of periods N, which is not going to be 1.5 years, but rather 18 months, which is 1.5 times 12. Those are the new things, minus 1 divided by the rate, once again being not 12, but 12 divided by 12, which would be 1%, the monthly rate. Okay, so let's do it. Let's do it then. Let's do it in our table format. We'll do the table format. So on the outer column, we got the 1,000. Then we've got the numerator. The numerator, which is going to be then 1 plus the rate. So we're right here. The rate, now the rate is going to be equal to the 12%, but we're dividing it by 12 for the monthly rate, making that a percent. Home tab, number group, percentifying it, 1%. Font group and underline. Then we'll get the subtotal, which will equal the sum of shift 9, up arrow, holding down shift up again and enter. Let's make that a percent as well by going to the home tab numbers. You can add some decimals, 1.01, or make it a percent, which would be 101%. Then we'll take that to the number of periods. We're right here in the formula, so we're going to take that to the number of periods, which we could say is called n in our formula, and that n is represented by the 18, which is in months, so it's not 1.5 years, but 1.5 times 12, or 18, and we're then going to underline that, home tab, font group, and underline, and that'll give us, let's call it another subtotal, and this is going to be equal to the 101%. Shift 6 to the caret of 18, enter, adding some decimals to that so we can see what's going on there. Home tab, number group, decimalizing it. Decimalized. Okay, and then we're going to say less $1 right here. We're right there on the numerator, still 1. Underlining that by going to the home tab, fonts group, and underline. And then finally, we'll bring that out to the outer column, and we'll call that the numerator. Numerator. I can't. Okay, here we go. This is going to be equal to this number minus the 1. Adding some decimals. Home tab, number group, decimalized. So there we have that. Let's do some indentations here. Let's select these items. Go to the home tab, alignment, indent. This item, home tab, alignment, indent. So there we have that. And then we just need the denominator, which is the rate denominator. I typed it better that time. Well, it was faster. I'm not even sure if it's spelled. If I spelled it wrong, I apologize. But the rate is going to be the 12% divided by 12. That's the new thing because we need the monthly rate, not the yearly rate. Home tab, number group, and percentify that. Font group, underline it, and then we'll add it and make it another subtotal, bringing that to the outer column. That's going to be this whole thing that we finally got done calculating, which is going to be equal to the numerator divided by the denominator, making that a decimalized number, adding decimals, home tab numbers, decimalize, and then font group and underline, and that's going to give us our future value of an annuity calculation. Finally, just multiplying this outer column out, which is going to be equal to the 1,000 times that decimalized number we came to. Let's add a couple pennies here. Adding pennies, home tab, number group, couple pennies, 19,614.75 about. Let's do it one more time. And this time with tables. So I'm gonna hide some from K to O now. Put our cursor on column K, the skinny column there, and then go on over to O, let go, right click, and hide. So from the table, we're gonna have the payment. This is what you might do in a classroom setting, payment. And the payment's gonna be the 1,000. Then we just find the amount from the table, noting that you gotta have the right table. This is an annuity table that we're looking at. So we got the future value of the annuity. And then we got, notice in the past, the periods and the rates represent yearly rates and years. Now they represent months. So that means we have 18 months here. And then the percent isn't 12%, but 12 divided by 12, or 1%. And you can see why we picked 12 as the percent, because 1%'s on the table. An uneven percent would not be on the table, and anything below 1% would not. Therefore, if I chose a yearly percent of anything under 12, it wouldn't be on the table, and anything that's not evenly divisible by 12 wouldn't be on the table. So that could be useful to know in a school setting if they're going to be using the tables. So we're going to say we got 1 and 18 then. 1 and 18 brings us to the 19.615. So 19.615, that's from the table. Let's add some decimals to it. Home tab, numbers, decimals. Make an underline, font group, and underline, and that's going to give us our future value of an annuity. Multiplying this out, 1,000 times the 19.61, and we're going to add a couple decimals. Home tab, number group, couple decimals. We're at the 19.615. Let's unhide some cells and just recap what we have done. Putting our cursor on column B, dragging on over to column Q, right-clicking on it, and unhide. So now we did this with the running balance, getting us to about 19.615. We did this with the annuity formula function within Excel, 19.614.75. Got to that same more exact number, more exact than the tables at least, of the 19.614.75 here. And then on the tables, we got to the 19.615, slightly different due to rounding, noting that this amount here from the tables rounded to 3 to 4 digits, whereas the actual number we can see from the mathematical formula is not rounded to 4 digits, but continues on, resulting in that rounding difference.